Hi, in this video we will learn about another property of determinant of square matrices which will help us sometimes to have easier computations of determinant. It says the fact or the theorem or I don't know the property you like to say, the determinant of a matrix with two equal rows. So if it has two rows which have exactly same corresponding components, equal rows or columns. So two columns which are exactly same or two rows which are exactly the same. The determinant of such matrix is equal to 0. You don't need to do any computations for that. Okay. Well, this proof of this, you need to do a little bit of work, but let me just give you some clues, and then from there you can see it yourself. That determinant of a 2 by 2 matrix which have the same rows, let's say A11, the first row AB is equal to the second row. In that case, we have AB minus BA. These are the same thing. This is equal to 0. Yeah. But this is obvious for 2 by 2 matrices. For some, for 3 by 3 matrices, let's say the first row is equal to the last row, then A, B, C, D, E, F. So in this case, what you need to do, you expand along a row or column which is not one of these two. So I expand along the second row here. So it will be D times, well, this is plus minus determinant of BC plus E times plus determinant of AC. Yes. And then the last piece is F times minus determinant of AB. And as you can see, all the submatrices will have two rows equal to each other. And we showed that in 2 by 2 matrices, if two rows are equal to each other, then the determinant will be 0. So all the cofactors will be 0 in this case. And that means that the matrix is 0. Well, this then you can go for 4 by 4 matrices. Then when you're doing the determinant of a 4 by 4 matrix which has two equal rows or equal columns, you expand along a row which is not one of those two. Then all the submatrices will have two equal rows. Then, well, you continue going down, continue one more time applying the expansion, cofactor expansion, and it will give you 0. Well, the proof, if you want to make it very precise, this needs mathematical induction, but learn the fact. If a matrix has two equal rows or equal columns, then the determinant of that matrix will be 0. Okay, let's do these examples here. So these row 1 equal to row 2, the determinant is 0. Here, you have to look a little bit carefully. Column 1 is equal to column 3. So then the determinant is 0. How about this one? Okay, this is 4 by 4, and it's very important because if there is no such a equal rows or columns, then you have to do a lot of work to compute the determinant. But if you look a little bit carefully, you notice that, okay, row 1 and row 3 are the same, so the determinant is 0. This is another property of determinant that you have to keep in mind. We will add to the list of these properties which can be used as shortcut to compute the determinant of square matrices.